All right, it is Advent of Code, day 17. I am doing this from a Starbucks again, and yeah, here we go. Let's go. Okay, some kind of grid. Best way. Okay, this is definitely going to be. Nice heat loss. Doesn't require to go in a straight line. Okay. City block, legit heat loss enters that block. This is like a dexterous thing purely. Moving most 3 blocks in a single direction. Okay. Okay. Good thing I have this written. So we do need the grid. What we're gonna do. So our states will be. So start. States will be a location. Where do we start from? Top left. 0, 0. And then it needs to be like the direction we've been going in so that we don't go too far in one direction. Or we can just produce adjacencies like, yeah, well, I'll just do that. The direction wants to turn 90 degrees. Oh, it can't reverse direction. Okay. Interesting. Yeah, so we'll do... and then the direction we've been going in, and then the number of steps we've been going that direction. I don't actually know what this is. Yeah, I'll need to redefine it so that I can get it to go like clockwise. Or not clockwise, but like any... I just want it so that if we increase by index, we're returning... Index by 1, we're returning by 90 degrees. Okay, and then start by going in this direction for 0. That's our state. And then what we'll do is just start as if it's 0. Okay, so, so we don't incur the first block. Is that right? As you restart, you don't incur it until you leave that block and return to it. Okay. And then for the adjacencies, that's going to be, let's see. So we can always either turn left or right. So we'll do dist, then cur. But cur is actually going to be... I'm trying to think. Yeah, I think we do need to include this in the dists. Okay, so cur, and then direction, and then a number. Blaster, number of steps in that door. Okay. And then if this is equal to n minus 1, n minus 1, then we break, print dist, and then we break, right? Okay. And then otherwise, if n steps is less than 3, then we can consider let's do like this. It's less than 3. Then what we can do, this is per cx cy. So states need to be the same, and then x dy is last dir. Oh, whoops, must be dirs of last dir. This is index, remember? And then we can do yield cx plus dx, cx plus dy. We can keep the direction, so this doesn't change, and then we can increase the number of steps by 1. That's the thing we can do. And then the thing we can always do is we can always rotate. So for ender in -1. We can always go in this direction. So cx dy is equal to per, dx dy is equal to dirs ender, yield cx plus dx, cy plus dy. New dir, and then number of steps we go in the direction is just 1. So we can always do that. Like as our adjacencies, and we can't go outside of the board. And sorry, we also need to yield the cost. So the cost of taking that step is always going to be, well, here we'll just do like this, and then the cost is going to be if an x and y is adjacency of 0, if an x not range n, or an y not range m. Okay, if it's out of the grid, we can't do it. Otherwise, the cost is the grid of an x and y. Then I think we just do this, and then our answer is the final distance that we got. Okay, that didn't work. Elder. Let's make our start be something like. There we go. Okay. D. Oh, whoops. This needs to be cost. That's the heat loss. Ooh, that did not work. This adjacency. Wait, what? And then N? Why did we. Well, NPQ is. I'm pushing to the heap here. Oh my god, I can't believe I'm having bugs in this. Okay, so we are getting two adjacencies. So at the beginning we can go in any direction, so this is not really right. Let's do like going in the. I think that direction is fine, or 0 steps. That should work. Okay, still not working. Wonder why. Okay. There's one that's out of bounds. That's fine. And then we're getting this. We have dists of. Oops. Typo. My dextrose. That is terrible. Oh, terrible bug. Didn't cost me a ton of time. Might have been too much though. Okay, well, good thing I added my print suppression. Oh, that's so annoying. And what was the last curve we got to? We should definitely be able to get to the end. I'm very confused. Oh, it's because I did this. Very dumb. 758. Right answer, rank 11. Okay. Ultra Crucibles. Needs to move a minimum of 4 blocks before it can turn. Okay, this is easy. So now this changes to, we have to continue in this direction. Or even before. Wrench start to wobbly. Move a maximum of 10 without turning. Okay, so this is the one in the same direction. And if our steps is less than 10, then we can do this. And this is turn. And this is only now if 10 steps is at least 4. I think that's the only difference, right? Okay. And then, but now our start needs to be a little different because we either be going in the 0 direction or we can be going in the 1 direction. So let's add this as well. Let's do start 2. So the other thing we could do is direction 1. Yes. I think that should be correct. Okay, 887. Not the right answer. Okay. Some kind of bug in here. First, let's check if I read it right. Even more difficult. They also trouble turning. Needs to move a minimum of 4 blocks before it can turn. Start to. We move 1, 10. Also, I'm not breaking here. Let me just break, just so I can. Let's try a sample. 47. No, okay, that's not right. So, what are we doing here? So I think adjacencies of per blaster instance. So let's do start. Okay, and then if we have this now, we shouldn't be able to turn yet, so we have to go there. Three, 4. This kind of looks correct to me, to be honest. Now, well, that's out of bounds, so that'll get filtered out. That's fine. But now I think we can turn. So, why doesn't it take this path? Why can't it? Oh, it can't go all the way to 10 because. Wait, why is it 71 now? It seems like it should only be. It should get 1, 2, 3, 4, 5, 6, 7 nines. It gets 3 here, gets 3 there, 7 times 9. Yeah, it's a little weird. We're printing 47 now. It's not. Let me just make sure that this is still working. So we've taken 10 steps. Then it knows we can't go to 4-0. That's weird. Where's the wrong answer here? If it's getting 47, that's how many nines? Is it all these ones? That's then how many nines? I don't know. It's probably like It's probably like 15-ish ones. So it thinks it can only get like 3 nines or something. It's so weird. If I get rid of this, does it like do something intelligent now? Whoa, okay. Well, if I get rid of this, it should be the same answer as before, right? Yeah, okay. I mean, this actually makes sense. This is going the wrong direction. That is really weird. And if it turns, my adjacency function just looks correct to me. I guess I can do, and then once we do this step, we need to do last of the new one we're going to is, let's just do her, just so I can figure out the actual like path. Last of 411 is 410. It's not. Is it trying to like turn immediately? This gets reset to 1, right? I'm trying to see if it's doing like a quick turn and then that. But anyways, 410, 49. Whoa, what? It's trying to go back to the. What? If. Oh, it's. What? I don't know what it's doing. I feel like I should really understand this, but. Well, I guess I kind of understand it. It's like revisiting the previous cells. But. Maybe for starters, I'll just print per elder and steps. This is in the dummy example still. Okay. So it tries to go to 0-9, then 1-0. So it goes 10 steps over. Wait, why does this one not go 10 steps over? 2, 3, 4, 5, 6, 7. Am I doing this wrong? Was this like saying an unfortunate route like this one? Like that was not the actual minimum? 94? Oh, that was correct. Don't tell me I fixed the bug inadvertently. My prince. Okay, well, whatever. I swear, if I never had something wrong in the first place, this would be terrible. 887, that is a different number. It's not the right answer. Yeah, this is definitely not the optimal route in this example. This is like so confusing. I thought 71 was optimal. That's the clear. It must obey the rules if it got here, right? Hmm. I mean, okay, so like part of the problem was my last here storing like something wrong. It was storing this, not the full adjacency. This should really be like, if you want to be able to actually traverse through the whole thing, that's what you need to. Oh my god, I gotta get rid of my prints. Steps. And now what we can do, last 4140, 1. Doesn't it end on? Oh no, it needs to end. This is optimal, right? Because it needs to stop here. It needs to go at least 4 blocks, so we can't finish. Oh, okay. And steps greater than or equal to 4. Oh my god. I think that's it. I think that's my only bug. 892. Oh, rank 60. Okay. Oh, that was terrible. I was like... Okay, so that example was fine. It was my parsing of the example. Okay, the thing that I missed was that because it has to go at least 4 blocks, and at the... we want to, like, stop at the very end, it means that we need to have gone at least 4 blocks to, like, get to the end. And adding this as a goal condition is all it takes to get that. Wow, that is a terrible regression, going down from what was I, 11 to 60. But 60 is not that bad. Like I'm happy with 60 for sure. I just feel like I should have been able to realize that quicker, like a lot quicker. This could have really been like an 11-11 had I read that condition quickly, because it took me like maybe a minute to make that adjustment. 824. It probably took me 2 minutes. Then it would have been like 924. Yeah, that would have been, wow, that would have been insane. Oh man, that's pretty disappointing. Okay. But yeah, it happens. Cool. Well, definitely my print suppression came in very clutch here. Otherwise my terminal would have crashed and I would not have been able to, to like I would have just lost a ton of time like previous days. But cool, yeah, that is day 17. Today, I'm not gonna do a full explanation, but today was for the most part a like grid-based extras with a few fancy requirements on how we can like traverse the cells that require us to like modify the state. So normally you could just keep your state as a like x, y coordinates, but here since you have the requirement where you can't go more than 3 blocks in a direction, there's a few ways to do this. The one that I chose to do is to change my representation to have both the coordinates that we're currently at, the direction that we're currently moving in, and the number of steps to take in that direction. And then in my adjacencies function, you can add all sorts of requirements, the number of steps and changing direction. But yeah, that is all I have for day 17. Yeah, I mean, other than that, it was a straightforward dexterous. I say straightforward, but my dexterous in fact had a bug in it. This is mostly a textbook implementation of dexterous with like a few extra things. But yeah, dexterous is just the algorithm to find the shortest paths. So. But cool, that is all I have for day 17. I will see you tomorrow.